We live in the era of vibe coding. You have an idea for an app, you open Google AI Studio, click Get API Key, drop that string into your environment variables, and you're generating content in under 2 minutes. There is zero friction and no complex permissions to configure. But that speed is exactly the problem. By default, the key Google just handed you is completely unrestricted. It isn't tied to your specific laptop, an application, or a set of IP addresses. It's simply a string of text that will accept requests from anywhere on Earth. And text strings leak constantly. All it takes is accidentally pushing a hard-coded key to a public GitHub repo, bundling it into client-side JavaScript, or leaving it in a decompiled Android app. Once it slips out, anyone can use it. Within minutes, automated scripts scrape that key and start hammering Gemini's largest models with thousands of requests a minute. Because you own the project, your billing account eats the cost before you even know it's happening. Prioritizing speed over basic security can turn a morning of prototyping into a 5-figure invoice that hits your account before the first cup of coffee is cold. The absolute first line of defense starts the moment you create that key. You have to lock it down directly inside the Google Cloud Console. Under application restrictions, you get mutually exclusive options. You can limit usage to specific websites using HTTP refers, lock it to specific server IP addresses, or tie it to the exact package signature of a shipped Android or iOS app. You also need to create a separate, distinctly named key for every single application or environment. If one key is shared across 5 projects and traffic spikes, you have no way of knowing which app is compromised. Isolating them contains the blast radius. However, tweaking settings in a console doesn't help if the key itself is hard-coded into the deployed client code where anyone can read it. The solution is to move the credential into Google's Secret Manager. On a platform like Cloud Run, the service securely pulls the key from the vault and injects it at deploy time, meaning the string never touches your code or disk. Locking down the console perimeter and completely evacuating the key from your codebase eliminates the surface-level vulnerabilities responsible for almost all of those overnight billing spikes. But if you try to restrict a key to specific IP addresses on a serverless platform like Cloud Run, you hit a structural problem. By default, Cloud Run sends outbound traffic from a constantly changing pool of shared IP addresses. To fix this, you have to upgrade your network architecture. You deploy a custom virtual private cloud and route outbound traffic through a Cloud NAT gateway. This forces every API call to exit through a single static IP address that you can safely whitelist. Even with a static IP, API keys are ultimately just bearer tokens. Once a project moves beyond the prototype phase, the safest approach is to abandon AI Studio keys entirely and migrate to Vertex AI. Vertex AI doesn't rely on vulnerable text strings. Instead, it governs access using Google Cloud's native identity and access management system. You create a custom service account, assign it the specific agent platform user role, and let your application run as that identity. You never generate or download a JSON key file to manage. Moving to Vertex AI's identity-based governance removes the physical bearer token from the equation. Because there is no key string to hardcode or leak, the most common entry point for API abuse simply ceases to exist. Even with a hardened network and strict IAM rules, you still have an operational blind spot. Cloud billing exports lag behind actual usage by up to 48 hours. If a bug in your code starts burning tokens in an endless loop, you won't know until the damage is already done. To close that gap, you need granular attribution. Vertex AI allows you to inject metadata request labels directly into your API calls. By tagging every request with the specific application feature and the user ID, you map every token burned to a specific action. Those tags are then passed into structured token logs. Instead of waiting for the billing dashboard to update tomorrow, every request is instantly tracked the second the model responds. By upgrading your Google Cloud Log bucket to support log analytics, you can run SQL queries directly on those structured logs. You can instantly pinpoint exactly which user or which experimental feature is driving a sudden spike in traffic. Your absolute final safety net is a cloud billing budget alert. To avoid false positives from other infrastructure, you isolate this budget so it only tracks spending from Vertex AI and the Gemini API. You set tiered threshold rules, sending notifications when spending hits 50, 80, and 100% of your expected limit. This ensures you get a warning while the financial impact is still small enough to manage. Intentional architecture, using layered restrictions, IAM governance, and real-time observability, ensures that Gemini remains a managed, professional asset rather than a hidden risk.